Okay, significant figures are measured values. They're how many digits of precision you have. And the trick is zeros. And the thing to remember is leading zeros, like the ones we have here, ones that come before the first number, are never significant. Trailing zeros can be significant if you have a decimal present. The trailing zeros are significant. But if there is no decimal, then the trailing zeros are not significant. With that in mind, let's look at number 1. There's no trailing zero, so therefore the 9 and the 8 are significant, so we have 2 significant figures. If we look at number 2, all our numbers are significant because a captive zero, one that comes between two numbers, is in the case between the 3 and the 8, those are always significant, so I have 1, 2, 3, 4, 5 significant figures in that one. If we look at the next one, leading zeros, the ones that come before the numbers, are never significant, therefore I have the 7 and the 8. That gives me 2 significant figures. Now if I look at the next one, there are zeros but there's no decimal, so trailing zeros, ones that come after the number without a decimal, are not significant. That means I only have 1 significant figure for number 4. If I look at number 5, I have both a captive zero between the 6 and the 8, and I have trailing zeros. So the captive zeros, they're always significant. Trailing zeros are not significant without a decimal, so therefore I have 1, 2, 3, 4 significant figures here. Now if I look at number 6, I see I have leading zeros, not significant. I have a trailing zero. Trailing zeros are significant if the decimal is present, so this one counts. So I have the 4 and this 1 trailing zero. That gives me 2 significant figures. If I look at number 7, what I've got is trailing zeros, but there is a decimal, so these are measured values and therefore significant. I have 1, 2, 3, 4 significant figures here. We look at number 8. I see a lot of trailing zeros, but I don't see a decimal, so therefore I only have 1 significant figure. Now the next one, number 9, I see I have trailing zeros and a decimal, so therefore what I have is the 5 and the 9 are significant, and these 2 zeros are also significant because there's a decimal, so therefore I have 4 significant figures. And then with number 10, what I have is I have leading zeros, not significant. Trailing zeros, in this case, they are significant because the decimal is present. So remember, is the decimal being present makes the trailing zeros significant. I wouldn't have put them here. They're not placeholders. I only put them here because I measured them. Therefore, what I have is 1, 2, 3 significant figures. Whoops. I have 3 significant figures here. Okay, now let's see how to actually round our answers for significant figures. That's really what I'm interested in having you learn to do. That's the main skill we need to get good at here. Okay, so if I look at number 11, when I enter these numbers into my calculator, what comes out is 2.68529 blah blah blah. Well, if I look at it, what I have here is 3 significant figures here and 2 significant figures here. The rule is you always round to the smallest number of significant figures that you're using in your calculations. Think of it like the weak link in a chain. This is my weak link. This is a weak measurement. This is a strong measurement. I can only be as certain as my weakest certainty. I get 2 significant figures, so I get to keep the 2. I get to keep the 6. I look at the 8. If this number, after the one I'm going to keep, is 5 or greater, I would round this up. So in this case, I'm going to round my answer to 2.7. Let's look at the next one. So the next one, the answer is going to be 80563.8. Now that's a lot of numbers, but how many significant figures do I really have? Well, here I have 4, the captive zero counts. Here I have zeros, trailing zeros with a decimal, so they count. So here I have 1, 2, 3, 4, 5 significant figures. Here I have 1, 2, 3, 4 significant figures. So this is my weak link. I get to keep 4. 1, 2, 3, 4. But now notice I don't get to keep the 3. All right? So I'm going to go here and say, well, I get to keep the 8. I get to keep the 0. I get to keep the 5. And now I get to keep the 6. But that's my 4th one. I look at the next one. That is less than 5, so therefore I'm going to leave the 6 as 6. But if you'll notice, this here 8,056, that is not the same thing as 80,563. This is not a rounded version of this. So the trick here, and this is a hard thing for kids, I have to add a placeholding 0. I need for this 8 to be in the 10,000ths place, not the 1,000ths place. Now notice, because there is no decimal in this, this 0 is not significant. I know this is tricky. The good news is it doesn't happen that often. Let's look at the next one. In the next one, I'm going to get 0.0637 25 blah blah blah. Well, if I look here, I have 2 significant figures here, I have 4 significant figures here, I get to keep 2. Now this one here, that is a leading 0. That is not a significant figure. That is not one I'm keeping. I've got to keep 2 significant figures, so therefore I'm going to keep the 6. I'm going to keep the 3. I look at the 7, since this one here is 5 or greater, I'm going to round this one up to a 4. So what I keep is 0.064. Let's look at our next one. The next one, what I get is, well, your calculator is going to do something odd to you. You're probably not going to like it. Chances are your calculator is going to say 6.6903 e minus 4. Now, we haven't talked about scientific notation on a calculator yet. That's what it's doing. We'll talk about that tomorrow. But we can do the significant figures. Leading 0 is not significant, therefore I have 1, 2, 3, 4 significant figures here. I have 2 here. So this is my weak link. I have to round to 2 significant figures. So what that means is I'm going to keep this 6, I'm going to keep this 6, and since this is 5 or greater, I have to round this one to a 7. So I'm going to write 6.7, and I'm going to say e minus 4. And we'll talk tomorrow about what this means. Alright, let's look at our next one then. In this case, when I calculate it, I get 136.75 blah blah blah. And now if I look here, I have 3 significant figures here. These trailing zeros don't have a decimal. They're not significant. Therefore, I have 1 significant figure here. This is my weakest link. I get 1 significant figure, and there it is. I get to keep the 1 in the hundreds place. Since this is less than 5, I'm not going to round the 1 up, so I'm just going to write a 1. That's the only one I get to keep. Now clearly 1 is not the same as 100, so I had to put 2 placeholding zeros in order to keep this 1 in the right place in the column with the hundreds. Let's look at our next one. Number 16, the answer that comes out of my calculator is 633.86. I'm going to look at my significant figures here and say, well, I have 2 and I have 3, so I have to round it to 2. I'm going to keep the 6, I'm going to keep the 3. This is 4 or less, so this stays at 3. And so what I'm going to get is 6.3, but no, 63 is not the same thing as 630, so the answer is put a placeholding 0. And so I have 2 significant figures, but I have a trailing 0 that's not significant. If I look at number 17, the answer that comes out of my calculator is 0.072445, blah, 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 blah. Now, I have 3 significant figures here. I have 4 here. My weakest link is 3. I get to keep 3. This one, and this one. That one there is less than 5. So this is a mercifully easy 0.107. If we look at number 18, the answer that comes out of my calculator is 621018. Now let's check our significant figures here. I've got 3, I've got 5, so I have to round it to 3. This one, and this one. This one is less than 5, so I leave the 1 alone. So I get to keep the 6, the 2, and the 1. Now I have to make sure I use placeholding zeros to keep things in the right place, so I'm going to need to have 3 placeholding zeros. Let's look at the next one. For number 19, what I get is 177.64, and on and on and on. But I have 3 significant figures here. I have these leading zeros don't count as significant, so I have 2 significant figures. This is my weak link. I get to keep 2 of these numbers. this one, and this one. Now in this case, this is 5 or greater, so I have to round the 7 to an 8. I get 1, 8. 18 is not the same thing as 1700, so I have to add 2 placeholding zeros to keep the 1 in the thousands columns and the 8 in the hundreds column. And we have one more we're going to look at here in a second. Let's look at number 20. When I calculate number 20, when I put in my calculator, what I get is 1.48214.5. Now I go and check how many significant figures. I have 2 here, I have 5 here. This is my weak link, so I'm going to round to 2 significant figures. Remember, leading zeros are not significant. I get to keep 2, I get to keep the 1, I get to keep the 4. This is 5 or greater, which means this one must be rounded up to 5. So I have 1.5. Now when we go to take a measurement, we have to keep in mind significant figures. We can only write down the numbers we actually measure. So if I look at number 21, what I see is I know this rectangle here is more than 10. I know that it's more than 20. So I'm going to estimate the digit beyond this. So I know the 2 for the 20. I know the 20s place. Now for the 1's place, I'm going to look at this and I'm going to say, you know what, I think if I imagine 10 tick marks between here and here, I think it gets to the second one. So I'm going to call this 22. Now you got to keep in mind we're probably going to be plus or minus 1 from each other when we do this one, because you might see 23 or 21. I see 22. So let's look at, speaking of 22, let's look at number 22. Okay, in this case, I see that I haven't quite got to 10. I know it's more than 0. I know it's less than 10. I'm going to picture 10 little tick marks, and I think it gets to the 8th one. So I'm going to record this as 8. Now notice what I have here is only one significant figure. Here I have 2 significant figures. If I look at number 23, I should get even more significant figures. Here I know it's more than 3. I know it's more than 0.6. So I'm going to write the 3.6 part. And now I'm going to estimate that last bit. So when I look here, I think, I think it's about maybe 2/10 beyond that one. So I'm going to call it 3.62. And again, there's probably going to be plus or minus 0.01 on that one. Okay, let's try numbers 24, 25, and 26. Okay, so when I look at number 24, I see that I know it's more than 2, I know it's less than 3, so I'm going to write down 2 point, and I'm going to estimate how many tick marks, and I think it's gone 9 tick marks. So I'm going to call it 2.9. I can't go any more than that. I only get one digit of estimation. Now look what happens here on number 25. It lands right on the 3. In my mind, it looks right on it. So the trick to these are to say, look, you know what? If it was 1 tick mark before that, which is a little bit before that, you would call that 2.99. Because you'd know the 2, you'd know the 0.9, and you'd estimate the 0.9. Well, I don't think it's 2.99. I think it's right on the money, so I'm going to call it 3.00. And what I'm saying to you is that using this ruler, I could have measured that to 3 significant figures. Remember, if the decimal is present, the trailing zeros are significant. That's a 3 significant figure answer because this part of this ruler can be read to 3 significant figures. Let's look at 26. Now, by the way, I know that 25 is kind of a hard one. Okay, let's look at number 26. It's the same principle. It lands right on 2, but instead of calling it 2, if you just write 2, you leave the person to think you're estimating that, because you always get one digit of estimation. Instead, what I'm going to do is I'm going to say, well, if it had landed here, I would have called it 2.1. If it landed here, I would have called it 1.9. That's 2 significant figures. Since I think it fell right on the money, I'm going to call it 2.0.